Hi, thank you everybody for joining here, especially after the previous talk. Uh, we're very excited to share with you some advantage and walk you through our journey that we went through for building the language and contributing to the DeFi work, which is one of the most growing aspects here today. Lex was talking about it earlier today, and yeah, and we'll follow up from there. So the main instrument and contribution of what we're actually building is an ability to create financial contracts with on-chain execution that represent financial derivatives. Um, the size of the market of financial derivatives is by far larger than what we see today in the DeFi world. We have locking up of about $500 million in different kind of DeFi applications, and consistently, this market has been north to $500 trillion, which is a number that's a little bit hard to comprehend, at least only. When we're discussing and thinking a lot about the industry we are living in, right? The whole capitalization, including Bitcoin, including everything today, is $264 billion. It's a fraction of what we see in the other derivative markets. If we take only Amazon alone, it's 3 to 4 times the size of the full crypto space today. And further than that, if we compare it to gold, which a lot of the comparison between Bitcoin to gold as digital gold, we're reaching about 7 trillion market cap. The world GDP is roughly 8-9 times that and getting to 85 trillion market, and that is a fraction of what we see in the trading of financial derivatives market. To discuss a little bit more about why smart contracts are used, and that's everybody here is kind of, I assume, buying into this concept, right? We talk a lot about remove intermediaries, getting a more transparent value proposition, being able to see transactions, and we're getting this sort of immutable handshake that is what the first blockchain and Bitcoin applications are all about. So we know someone is really signing this contract, it's immutable, and it's running on chain. But while there is a lot of discussion around the scalability issues, security is a really large milestone for that space on. Very specifically because, I mean, everybody in here in this space have heard the cases of the DAO hack, roughly $160 million, $150 million at that valuation of ETH, which was about 8% of all ETH in circulation, the parity wallet bugs. So we actually know that we are exposed to a severe risk, cybersecurity risk, and risk of execution of any contract debt. And in order for that industry to grow and to get real adoption, we have to get these contracts to really have transactions which are secure. I don't think that if we see this industry as the basic of the fintech sitting on blockchain infrastructure, we cannot do it when transactions have to be reverted, and they cannot be reverted on the platform. And that is not just an issue that is measured by a couple of brain examples. This is like the tip of the iceberg. Some research looking into blockchain contracts on the Ethereum network found about 45% of all contracts have vulnerabilities. And these vulnerabilities can affect us largely if we want to create infrastructure for financial contracts. Taking it forward, and that was the reason why we really look and created Lira and use that to contribute to this space. Yeah, Lira, not Libra. It's referring to the old Israeli currency, and also Turkish and Italian and many Europeans. But what you see here is actually a good example of what is created. If we look at the example here, you make a trade here for 10 Bitcoins for 555 each, and all this trade is measured in this very, very small piece of 5 lines of code are actually presenting all what you need to do in order to develop it in a formally verified language and that execute on Ethereum. So let's get a bit deeper into that. So formal verification is tool used historically for building airplanes on software that cannot fail. And I think most people do see software in the financial sector as such that cannot fail or should not fail. And this is the infrastructure that is used for what we build in Lira. It's based on a lot of research that was done in my university. We built it over several years. The language that is based for that has been formally verified for the contract. The second element is really that by creating a separate language, we do not have to revert to Solidity, and we can also transfer it to a variety of different infrastructure. We have written a compiler directly to EVM, to the bytecode of Ethereum, so it's run directly on Ethereum, but this language is different than Solidity and others, and the compiler can be mildly modified to support the vast varieties of other blockchain, and everything which is compatible with EVM, it works already. In the same context, and maybe I will sit down here and show you how easy is the code that has actually built the derivatives you've just seen before. And closer, all right. So, everybody that has experience with writing some code with Solidity would know that writing a future contract will require hundreds of lines of code. All what you see here in the side is what required to write the contract before. We have an operation here, and which is part of our insight for the language for financial contracts, is that financial contracts are a finite amount of transactions. Using finite amount of transaction, you don't need a language which is Turing complete, which means you can actually create it in language which is more safe. And you also been able to use a DSL that we created to that purpose. The ones that want the more technical explanation are welcome to our workshop at 11:55 when we're going to walk through that and run a couple of live examples. So in the code here, Bob transferred to Alice 55.5 ETH for each one Bitcoin that Alice transferred to Bob. They both just operate them to become atomic operation that happen at the same time. Then we scale it to 10, and that just means 10 Bitcoin to 555 ETH. And we translate it 90 days, which means wait 90 days before you actually execute that. That's all the code. It's actually written in a language that is readable for human in comparison, and it's quite easy to execute. To discuss some of the implication of that also to the DeFi industry that is growing very largely, if we look here into a couple of the DeFi component, we know that while this industry today have $500 million market cap, it requires over-collateralization. Why is that? You loan funding for someone you don't trust that can run away. So if you require less collateralization, the counterparty will run away. But this is not really the fundamental use case of lending. The fundamental use case is building a mortgage case. I'm going to my bank, I maybe has 10% off the cost, and I loan an additional 90%. So I need to have a fairly marginal amount of the money needed for the underlying. Because the traditional future contract, and that's the reason why this industry is so large, has the fundamentals that they start in fair price. If you remember our example before, we said one Bitcoin is 55 ETH. So you really look at the difference between that price for your margin requirement. So we can really reduce the margin requirement to be fractional, which is interesting and good support for this space. We'd love to talk to people in the DeFi space on that and see how to integrate it to what they are doing today. But more importantly than that, we want to show you live demonstration that you're all welcome to try yourself. If you come to demo.lira.org and you connect with your MetaMask to the Covenant network, you can receive from us, as you see in the get in the side here, from each of these tokens, copies you can actually use locally. And if your ETH amount is below 0.1, we'll instruct you how to get more ETH on Covenant. Let's run through an example. So we're going to choose an asset to trade. We'll trust with wrap ETH as our base asset, and we refer to USDX, which is eToro stablecoin representing US dollars. We're going to take 2 wrapped ETH to trade. The exchange rate is taken automatically as part of it, and you can see the asset. Now, the usual case on future contracts is you run it 1 month ahead, 2 months ahead. But in this specific case, we want to run it in 40 seconds because we want all of you guys to actually follow the full execution. So let's do that, and I hope that Google will be kind on us and doesn't give us quizzes. So we can now create the contract. Notice that we have 1,000 of each of the assets on the right side here, so we can see what we need to do. Now the contract is deployed on the chain and is now waiting for our approval. Once we're going to approve that, we're going to have 2 wrapped ETH taken from our account here to be kept in collateral. Please, we confirm the transaction on MetaMask and approve that. And And once it happens, the code itself is going to be executed. And at the same time, we'll see in a second or in a couple of seconds the 2ETH balance refresh and reduce here while the code is in progress. Let's wait a second for it. And once at the time we do this, we can actually see the code that actually created this contract in the backside. You can actually check it out before you actually approve each of these contracts. It's very similar to the example we have seen before, 2 transfers. Yeah, the 2 ETHs are now updated and were taken into the collateral. We'll wait an additional 10 seconds for the contract to fully run and execute on Ethereum. And then what we will see after that was that 337 USDX will be transferred after the refreshment happened to a site. Now it's finished. Now we'll have the code executed. When the execution is over, it's going to be green, and our balance will be changed from USDX to receive the additional 337. You are all very, very welcome to try it yourself. Everything I've done here, you can do yourself to check it out. The code is fully operational and open source from today. You can see that. You can play with it. We have a link to our GitHub down here below in the demo. And you can actually, you can see the balance has changed. Maybe wait a second. The dollars has passed. You can see our GitHub where you have full specification of the language. If you move to the side afterwards at 11:55, we're actually going to run a couple of examples. And we further do a 2 hours example in DevCon on how to use it and the libraries for the language. We would love to see if you can help us in this journey. If you have feedback, if you have some justification for your own DeFi application, if you want to collaborate with us or contribute open source, we will share our problems. And thank you very much.